I'm here with Chris Strutt from University of Southampton, and you're an expert in
geographical surveying and
ground penetrating radar and all the high-tech gizmos. So what brings you to Nevis?
Well, originally came out with a Lane Morris in 2002 to do a geophysical and topographic survey of the site at Hickman's, the Amerindian settlement, or settlements. And that consisted of us doing a full topographic survey of the site, getting all the guts and the range of elevations mapped out, and then conducting a magnetometer and resistivity survey of part of the site. And the issue is with being a volcanic island, the magnetometry wasn't particularly good. It just picked up a lot of the kind of subsurface geological features. Yeah, and
colonial sites.
The archaeology didn't appear clearly enough in the results, but the resistivity was quite hopeful in the sense that it was picking out things like post holes, gullies, ditches, post-packing stones especially. The issue being that the ground was so dry that it took us probably about 4 days to conduct a relatively small area.
That wouldn't be a problem today.
No, it wouldn't. Not with the weather we've got at the moment. So the idea this year is to come back and this time use ground penetrating radar or ground probing radar, GPR for short, as a technique that is, I suppose, doesn't require the sticking of probes in the ground, so the fact that it can be quite dry isn't a problem. To try and cover as much of certainly the north side of the site as we possibly can between the north gut and the kind of manchineel that grows across the site from west to east.
Now, I was hoping to videotape you actually, in the process. Is it, like I've seen on TV, it looks kind of like a lawnmower where you push it across and it picks up.
Yeah, pretty much.
Like on Pine Team, I've seen them.
Yeah. This one, the one we've got, it's very much like a pushchair or a pram with the antenna slung underneath, and then this kind of etch-a-sketch type thing that gives you heads-up displays of the data. So it's very similar. You have different ones. Some are dragged on a sled, others are slung under a cart. So we use the latter one usually.
Now, can you do it right in the field and you can see, okay, that's, this is there's a series of features here, or is it, because I've used some before and you have to wait to get in the lab to stitch, the tracks together and then have it rendered into a proper thing. Otherwise, you're just looking at little fragments like a jigsaw.
Yeah, I mean the way in which the technique works, I mean it fires a electromagnetic radar wave down into the ground and measures the time, two-way time, like time out and back in nanoseconds, and that the wave takes to propagate through the ground and come back to the receiver. So you're getting reflections at different depths going all the way down. One way using is 500 megahertz. So we reckon now on average it's getting down about 4 meters. But it's probably going a lot deeper and a lot quicker on the dry sand that we're dealing with here. We walk, so the antenna's slung underneath the cart. So you position the cart at the start of your line, and then you walk down each of the profiles, each of the traverses, and it collects this kind of section through the deposits that you're dealing with. And you build up a number of these different ones. Now, as you're collecting it, you can see what's coming up because you have a heads-up display that rolls along, showing the profile as you go. And at the end, you can review that profile and decide whether or not you want to get rid of it.
I've used them on boats, briefly.
Yeah.
And but it's hard to tell from one strip what you're looking at. It's not until you stitch all of them, the rows together, the ribbons basically together, and put them all together.
That's the issue. You're always dealing with something that's in section. You're always dealing with these kind of anomalies within the results that aren't as easy to interpret as things like magnetometry or resistivity. You are dealing with things like hyperbola and shapes and changes that don't actually necessarily represent the kind of cross-section of what you're dealing with. They represent how the reflection responds to those different.
So what's the main things you would be able to see with it? I know like the post holes and what else?
Any kind of changing interface where you're dealing with a different relative dielectric permittivity of the material, or RDP. So if you're going from, say, sand to a nice hard bit of basalt, you should be able to see that interface between the dry sand and that rock material. Things in terms of modern infrastructure that are really good are going to be walls, ditches, modern pipes,
pipes,
things like that.
This is an Amerindian site.
Now, this is Amerindian, so what you're dealing with here is, because you're dealing with more subtle changes, you're dealing with post holes, with packing, and things that are sandy deposits that have filled in a feature that's been cut into a midden deposit, which might have some shell in it, but is essentially very sandy as well. So any of those changes in interface should be represented in the results. It's just that the result the changes might be very subtle, especially compared with the more modern kind of colonial period archaeology, where you've got whopping great field walls and other structures. So we're looking for quite subtle changes in the results, representing these post pits and various other small scale.
What about burials? Would burials turn up?
Burials would turn up as well. I mean, we're currently doing traverses that are located every 25 centimetres to try and keep it a very high resolution survey. So there's no point in us doing half-metre resolution if the features are going to be sub 50 centimetres in size. We stand a very good chance of missing them. So we're doing as high resolution as we possibly can, and then collecting as many of those profiles. Now, as you said, a lot of the time with these things, you don't have a head-up display, and we can't really view the results in plan until we get back and download the equipment. So what we do is to take each of these individual profiles, bring them into the software, put in their locations, the start and end points in terms of coordinates, if necessary process the data, and then we reverse, because we're going zigzag, up one and then down the next. We have to reverse every other profile so that it's all facing the right direction. Once you've got it all in there and each of the profiles has been processed to remove background noise and various other things that we may want to get rid of, you then take those results and it kind of creates an XYZ data set of the changes in amplitude, and then slices the results kind of in plan, i.e. horizontally, and down through the data by groupings of nanoseconds. So you can slice every 2 nanoseconds, so it groups together that wedge and creates an image in plan of the area that you've surveyed. So you can see how the results change as you get deeper and deeper down through the deposits. Some things will ring through if you have very, very near surface metal, cast iron, say, pipes. They are liable to affect the results further down than the feature goes. So you get a shadow underneath that feature. But in general, especially if the features are very quiet, we should be able to get a good representation of the changing deposits as you go down through the site. In this instance, like I say, the antenna is probably going down a minimum of 4 or 5 metres, so that's more than ample for looking at the kind of Amerindian.
Most of the Amerindian sites, and I may be wrong, and as Elaine can correct me, would be multi-generational sites. Like, so a family group or a tribal group would be staying, over the course of several generations. They might leave for several months and then come back. Leave for a year, come back. So you wouldn't tend to have. Things would tend to be kind of mixed up, jumbled up, wouldn't it, over the course of generations of deposits?
Yeah, I mean,
you don't get nice, discrete. Here's a midden,
No, yeah, it's not that. This is it. It's all jumbled up. You've got post holes cut into midden deposits that are earlier, and so on and so on. And the issue with geophysics as well is it's not providing a kind of chronological handle, unless you're basically looking at form. So unless you can date it by form, you can't really get a very easy chronological handle on it without looking at other evidence.
With all the fancy tools and computer rendering and computerization, it still comes down to getting in a pit with a trowel and
I mean you have the ground truth. And the thing with geophysics is if it's not providing you with this chronological handle, what it allows you to do is survey an entire site in a relatively small period of time, and allows you to target your efforts. You could have a random sampling on a site and never hit a feature. It allows you to target those features and excavate them, and that provides a kind of chronological and material handle with which to date the site and understand it better. And that then kind of gives feedback to the geophysics, so you can then...
How long are you hoping to be here, assuming the weather cooperates?
The next week and a half, maybe for 2 weeks in total. So the aim is just to cover as much of the site as we possibly can.
Well, maybe we'll come back with the cameras and actually see the process and operation if this stops raining.
Yeah,
it's great to have you here, and I hope you're successful in your
pursuits.
Thank you.